My guest today is Ron Davison. I'm just looking at CO2 and what it does, and based on some of the more recent data rather than the whole history of it. The premise is, if CO2 is such a good climate driver, why doesn't it drive climate good? And that comes from the movie Moneyball. I've been following the IPCC and the global warming discussion since the early 1990s, when I was the lead engineer on a NASA gas disposal project in northern Alberta. Essentially, it's a CO2 sequestration project. It was 80% CO2 and 20% H2S. And so I was fighting climate change before it became fashionable. In 2015, I went through the process that many of your podcast participants have experienced. I really enjoyed seeing the presentations by the younger generation, like Tia Johansson and Lucy Biggers, for example. So what I do is I look at the empirical data for as many sources as I could find, and I take it a step further and download all that data to make my own charts and highlight some different perspectives, and you'll see a couple of those in this presentation. In 2015, I got involved with the Friends of Science Society here in Calgary and have been their president for the last 3 years. This presentation focuses on the data over the recent warming and the climate over the Holocene, briefly. And what does it show? CO2 has a marginal effect on our planet. I called this president CO2's Moneyball moment because it reminded me of a quote from Billy Beane, the Oakland athletics coach played by Brad Pitt in the movie Moneyball. My take, as I mentioned earlier, if CO2 is such a good climate driver, why doesn't it drive climate good? And note the slides do have links to more detailed relevant discussions. I'm just kind of touching on everything here. Okay. Now, this is one of the first plots I put together when I got serious about exploring the global warming concept. I very quickly found out that climate change is complicated. This is just 3 of the very many climate forcing parameters, none of which produce the whole story on their own. CO2 has the poorest correlation, in my opinion. And believing that CO2 drives the climate on its own is a simplistic and unscientific approach, and in my opinion, it's also dangerous and economic suicide. So how complicated is climate change? Well, it's very complicated. These are the radiative forcing best estimates put forward by the IPCC computer models. CO2 is, in their opinion, by far the most dominant warming parameter. That's the blue curve towards the top. But what do they not include? The ocean cycles, full spectrum of solar activity, and CO2's cooling parameters, among many other things. So choosing one very muted total solar radiance reconstruction of the 40 plus that are available is, again, simplistic and unscientific. Solar forcings, such as high energy particles and cosmic ray flux, while they're programmed into the models, they've effectively been turned off. So one of the problems with the IPCC computer models is that they have been self-acknowledged to run way too hot and use implausibly high emission scenarios. Fixing that problem is relatively easy, but I suspect unpalatable to the alarmist community. By making 2 easy changes, adding in the AMO, which they don't have in there, and substituting the TSI reconstruction based on 6 Akram reconstructions, and I'm not going to go into the detail on that. That's extremely complicated on its own. Replace that for the IPCC's 1 TSI reconstruction, the Mathis 2017 model. The models rely less on CO2, effectively reducing CO2's perceived radiative forcing magnitude. A more robust interpretation of CO2 would add to that reduction. So that curve gets squished down a little bit as you allocate more to solar or allocate more to urban heat island, whatever you want to throw into there. So I produced several history matches, and this again is the IPCC's best estimates with the such students I talked about. And I used a variety of parameter weightings. So focusing on CO2, including aerosols, that's the blue curve. You can match up the last 40 plus years, but it doesn't produce a great history match. And neither does focusing on solar activity on its own. and the representative ocean cycle, the AMO here. That's the green curve. I did not include that orange curve just for simplicity. Now, using the IPCC's total anthropogenic best estimate, the black curve, again, you don't get a great history match. The temperature rise and falls through the first 75 years of the 20th century just doesn't correlate very well to the anthropogenic narrative. There's also a deviation beginning in the 21st century here, which, if not for the strong ENSO pulses since 2014, it might have been even more dramatic of a deviation. So what does provide a good history match is a consolidated forcing. The red curve here uses the TSI and ocean forcings while maintaining a reasonable contribution from CO2 and aerosols. The standalone aerosol weighting is low here, but there is aerosol forcing intrinsic to the solar forcing. Anyways, the consolidated forcing makes a much better correlation than anthropogenic on its own. Okay, now this slide focuses in on Greenland, which holds roughly 10% of the planet's ice and is supposedly melting away. The black curve is the Atlantic multi-decadal oscillations, 20-year moving average. The green curve is the average temperature of all Greenland's weather stations. And again, 20-year moving average. And the blue curve is the atmospheric CO2 concentration. It's quite obvious which parameter has the larger effect on Greenland temperatures, and it's not CO2. A couple other quick notes. The early temperature drop in the late 1930s is likely influenced by the 1935 to 1957 Pacific decadal oscillation cooling. There was a sharp drop in cooling over in the Pacific, and some of that probably spilled over to the other side of the planet. And the correlation shown here uses the alarmist premise that solar activity is negligible. So suggesting that the M was largely responsible for the 1910 to 1940 warming. There wasn't much CO2 rise during that period. And most, now 87% plus, of humanity's emissions occurred post-1950. So it is abundantly clear that CO2, while contributing, is not driving the temperatures in Greenland. And somehow Greenland is not warming twice as fast as everywhere else in the world. It's less than a 1 degree per century rise in the weather stations out there. So that's CO2's first Moneyball moment. Now, switching to the South Pole, we find that CO2's influence on Antarctica's temperatures is almost imperceptible, if at all. Temperatures have been statistically flat for decades. It's another place on the planet that is not warming twice as fast as everywhere else on the planet. It's very cold there. Recently experienced their coldest 6-month period ever in 2021. And Antarctica holds roughly 90% of the planet's land ice, and it's not melting anytime soon. So CO2's second Moneyball moment. This slide just looks at the long-term extrapolations of CO2 concentration and polar temperatures. So starting with the CO2, the purple curve, if we continue our supposedly self-destructive emission curve course, Mauna Loa CO2 concentrations will reach 1,600 parts per million in a couple of centuries. That level is based on burning all the oil, gas, and coal reserves on the planet. The polar temperature extrapolations tell a different story. The NASA GISS weather station average temperature will not reach the melting point 0 degrees for 8 centuries. The University of Alabama Huntsville satellite Arctic data extrapolation would take 6 centuries. And the Antarctica extrapolation will be above zero for the next 43,000 years. We'll be back in a deep ice age well before any significant melting can occur in Antarctica. CO2 will just not melt the polar ice caps and cannot take us out of our current Pleistocene ice age. So somehow temperatures fluctuate independently of CO2 concentrations. The black curve here is the measured temperature in central England beginning in 1659. The red curve is the Hadkut 5 surface temperature data set. The two curves correlate remarkably well. Will that correlation continue back to 1659? Now, will remain a question, but we can certainly see that CO2 is not the only parameter that drives temperatures on the planet. The early 18th century rise is almost identical to the late 20th century warming. How is that even possible if CO2 is the primary climate driver? And why did temperatures start rising centuries before CO2? And why have the English temperatures only increased at 0.2 degrees centigrade per century? So this is just another place in the world that is not increasing twice as fast as the rest of the world. This, is CO2's third Moneyball. Okay, switching the discussion to sea level change provides our fourth CO2 Moneyball moment. CO2 has little to no effect on global sea levels. Despite the hype, sea levels have been rising linearly since the mid-1850s. There are small accelerations and decelerations, but they can be explained by the natural warming and cooling cycles of the oceans themselves. CO2 is not visibly accelerating sea level rise, and certainly cannot explain the declining sea levels pre-1856. So obviously CO2 does not correlate with sea level change. That statement applies to both sets of data shown. As shown earlier, the Georgieva data includes the rather inconvenient pre-1900 data that's declining. The Fredericksi data, pulled from NASA's website, starts in 1900, but exhibits the same acceleration/deceleration profile with a longer term, slightly lower linear trend. The satellite data shows that sea level rise is 3.4 millimeters per year versus the long-term extrapolations. But the satellite data only covers an acceleration phase. If satellite data was available from 1960 to 1978, I suspect the extrapolation would likely look much different. The IPCC sea level projection is programmed to honor greenhouse gas, primarily CO2 growth, in those computer models that are self-acknowledged to run too hot and use unrealistic emission scenarios. All this is one of the realistic ones, the SSP 2-4.5. This slide just highlights the deceleration-acceleration cycles corresponding to the AMO cooling and warming phases, and the logical extension, the purple part of the curve. The ocean cooling will likely decelerate sea level rise over the next few decades, as it has done in the past. Is that the only possible future? Absolutely not. The declining sea levels pre-1856, which would have had associated declining temperatures, point to a forcing far stronger than either the ocean cycles or CO2. The inflection point is the mid-1850s and is very likely solar related. It does coincide with an uptick in solar activity. That's the period where the Carrington event went off. When the sun switches from quiet to active and vice versa, the climate follows. Will the sun switch back to quiet in the near future? Well, we shall see. The last slide on sea levels. The larger plot from New York shows the linear trend present in the vast majority of tidal gauge data sets. A grade school student in 1910 with a ruler and a pencil could have projected today's New York sea level. Sea level rise is not accelerating despite rising CO2 levels. Not a problem, not an emergency. The smaller plot is from Pago Pago in the American Samoa Islands, where the UN Secretary General was trying to spread panic by suggesting the island was being overwhelmed by climate change-induced sea level acceleration. The acceleration there is obviously due to the September 2009 earthquake. There are some pre-1850 tidal gauge data available, but they're not shown here. The link at the top of the slide outlines some of those pre-1950 sea level and temperature data comparisons. Now, this is a plot of temperature and CO2 over the Holocene. I chose the vertical scales to reflect the alarmist position that CO2 is 140 parts per million,
rise is responsible for the 1.07 degrees centigrade temperature rise since 1850, as per the IPCC's 2021 AR6 report. It is abundantly obvious that the temperatures on the planet, both hemispheres, can fluctuate significantly with virtually no contribution from CO2. The natural forcings, solar, directly and indirectly, produce very pronounced temperature fluctuations in the Greenland GIFS-2 data. Those pre-modern temperature record natural forcings did not stop acting on the planet just because the alarmists have decreed it so. They were active from 1850 to the present and will continue to be active in the future, just not in the computer models that, again, have self-acknowledged to run way too hot. Now, the Milankovitch cycles are expressed in the long-term general trends here. The Holocene climate optimum, where temperatures were much warmer than today, and the steady decline over the Neoglacial the last 6,000 years are likely due to the obliquity curve from the Milankovitch cycles. On shorter time scales, temperatures do play out differently in the two hemispheres due to the differences in land and ocean percentages and geographical distributions. One thing we know about the Holocene, CO2 is virtually flat, so those temperature fluctuations weren't coming from CO2. Now, the alarmists like to show the CO2 curve plotted full screen, scaled for propaganda. Proper scaling is not so scary. I label the right plot as almost properly scaled for a reason. CO2 curve will constrict even more once more forcing parameters, solar activity, ocean cycles, urban heat island effect, etc., are factored in properly. CO2 does not act alone. It's fifth Moneyball. Now, I'll switch to the computers. CO2 climate sensitivity is not settled science. The plot shown here reflects only the general range of IPCC computer model projections. Russian models use a CO2 equilibrium climate sensitivity of 1.8 degrees centigrade. Canadians are at the top of the range at 5.7 degrees centigrade. Neither the Russians nor Canadians reflect the satellite temperature extrapolations. Both the UAH and NOAA STAR data sets are shown here. Now, the Russians roughly match the over-homogenized Hadkert-5 surface temperature data set. The Canadians, not so much. And using a reasonable emission scenario, the SSP 2-4.5, the Canadians are showing their true commitment to the science, and then they take it to fantasy levels with the implausibly high SSP 5-8.5 emission scenario. These are all the IPCC CMIP6 projections, all based on the SSP 2-4.5 emission scenario. And these are all available from the World Meteorological Organization website. Every scenario is running hotter than the UAH and NOAA satellite data. And most projections are running hotter than the over-homogenized Hadkert-5 surface data. Most alarmist evaluations will use the implausibly high SSP 5-8.5 emission scenario, which produces results even more ridiculous than the projections shown here. Do the alarmists really believe that averaging a bunch of incorrect projections will produce a representative version? To me, that's not science. All the IPCC projection runs are detailed here, normalized to the 1979 average temperatures beginning of the satellite period. As mentioned in the previous slide, all projections are running too hot. The Canadians are not on their own in producing exaggerated projections, but they are definitely contenders for the worst of a bad bunch. These are the scientists that Justin Trudeau and Mark Carney have been listening to. They all should have been fired long ago, in my opinion. Oops. Got to click there. The same data plotted in a different format. Every model runs hotter than the lower troposphere satellite temperature data sets, and most run hotter than the Hadkert-5 temperature data set. The low CO2 climate sensitivities, approximately 1.8 C plus or minus, come close to matching the temperature data, but they are still high and remain focused on anthropogenic warming forcing. Much of that radiative forcing should be reallocated to solar, wind, and other important parameters.
CO2's sixth Moneyball moment. CO2's seventh Moneyball moment takes us into the economic realm. Canada's Parliamentary Budget Office has estimated that climate change damage would reduce our GDP growth by just 6.6% by the turn of the century. Assuming our GDP grows by 2% per year, which is looking a little unlikely, that means instead of growing by 378%, we would grow by just 371.4%. We'll still be a rich country at the end of this, climate change or not. Full global compliance to the 2015 Paris Accords would only improve our GDP growth by 0.8%, just $17 billion at the turn of the century. It's just not worth the money. Now, the Parliamentary Budget Office is in line with work presented by Bjorn Lomborg on the left, 5.7% versus 6.6%. Both PBO and Lomborg use the implausibly high RCP 8.5 emission scenario. The reality is lower, as shown by William Nordhaus, a Nobel Prize winner in economics. GDP reductions globally are likely in the 1% to 3% range at the end of the century, using the IPC science, with reasonable estimates of solar, ocean, urban heat island effect, etc., forcings included. The total impact drops into the plus or minus 1% range. Lomborg also showed that how small the impact of the 2015 Paris Accord commitments would really have on emission reductions, just 1%, not even close. So we magically transitioned from the 2015 Paris Accords, which we could not afford, to net zero, not only unaffordable, but likely unattainable, all without the benefit of a comprehensive cost-benefit analysis. While not promoted, our Canadian government provided the estimates to do that cost-benefit analysis. Their 2022 budget put the net zero costs at $125 to $140 billion per year to 2050. That is $3.92 trillion just for Canada at the high end. The Parliamentary Budget Office report focused on the turn of the century reduction, but that 6.6% reduction, the climate change damage, adds up to $3.64 trillion over the rest of the century. So not a small number, but it's, we'll get into the detail here. Canadian taxpayers will be spending $3.92 trillion pre-1950, but slightly more, to save $3.64 trillion post-2050, and definitely less given the estimates are based on the implausibly high RCP 8.5 emission scenario. That basic cost analysis does not justify net zero, and those are still undiscounted dollars. Net zero does not benefit Canada's GDP growth, and as shown, there's no measurable benefit from temperature reduction. Linz and Happer and Van Wijngaarden have shown that the global compliance to net zero would avert 0.07 degrees centigrade based on CO2's warming capacity. With the IPC science included, positive water vapor feedbacks, that temperature rise reduction improves to 0.28 degrees centigrade. Canada's share of emissions, 1.5%, will lower future temperature rise by just 0.0042 degrees centigrade. That's unmeasurable and inconsequential. That works out to almost $10 trillion for every 1/100th of a degree centigrade Celsius of temperature rise that's averted. That's our eighth Moneyball moment. And sadly, the major spending does not stop once we reach net zero in 2050, assuming we have the financial material resources to reach net zero. Net zero makes 0 sense, and links are highlighted in blue. Bjorn Lomborg produced similar results when he evaluated the extended 2015 Paris commitments.
He showed a 0.1% degree centigrade reduction versus 0.2 degrees centigrade estimated by Lindsay et al. Emission reductions will have limited impact on future temperature rise based on the IPCC's own flawed models. CO2's ninth Moneyball moment. As Bjorn Lomberg has rightly pointed out many times, we have much more important issues, problems to spend our money on. Now, extreme weather analysis produces CO2's 10th Moneyball moment. All the data on this slide has been normalized to allow a representative set of extreme weather trends to appear on one chart. The normalized CO2 data has been rising continuously and accelerating post-1950. Extreme weather events, hurricanes, tornadoes, fire, drought, etc., are all declining or are statistically flat over the 1900 to the present period. Had I plotted snow extent, the trend would have been rising. But that is still contrary to the all CO2 all the time alarmist narrative. Rising CO2 is obviously not leading to more frequent or more severe extreme weather events. And all the attribution studies in the world, pseudoscience in my opinion, cannot change that very basic fact. Only the regression trends are shown here. Now, this slide provides an example of how the regression curves were produced on the earlier plot. The fire data shown here comes from three sources. The early data, not included in the red regression line, was pulled from Bjorn Lomberg's recent paper, Welfare in the 21st Century. It's well worth reading. The polynomial regression data, the red curve, is based on the US NIFC data, 1926 to the present. All that data, not just the data from 1983 to the present, that they make easily available. The brown regression line was produced by NASA and is based on satellite information. CO2 is rising, fire statistics are declining, and all the other curves were produced in that same manner. These charts just show a variety of satellite data sets confirming the decline in acreage burnt since the turn of the century. Bjorn Lomberg also produced a global historical reconstruction showing the general decline in acreage burnt and the accelerated decline over the satellite period. So forest fire data does not show an increase in extreme weather. Even the IPCC has low confidence in direction of change. For most climate impact categories, the direction of change is important and appears to be down based on the empirical data. If the IPCC were being honest with themselves, they would acknowledge that fact. And they only have high confidence in four categories for historical data. One, the mean air temperature has increased, which I agree with. Two, extreme heat has increased, but there are caveats there. The phenomenon is not global, and cold spells have increased with medium confidence in some areas as well. Three, mean ocean temperature has increased, and I don't argue with that either. And four, atmospheric CO2 at surface has increased. That's their only high confidence parameters that have increased. Not exactly a resounding endorsement of extreme weather events increasing. So rolling in the forecast to the end of the century only adds high confidence for ocean acidity, a misnomer since the oceans aren't basic, and more precipitation. And that is based on using the implausibly high RCP 8.5 emission scenario. So according to the IPCC, extreme weather events have not and will not cascade out of control anytime soon. Now, climate change discussion must include solar forcing, whether the alarmists like it or not. Two papers from 2023, Soon, Connolly et al., and Nicola Scafida have shown that there are many total solar irradiance reconstructions that do explain the modern temperature record better than the anthropogenic, primarily CO2 focus in the climate models. The Soon-Connolly paper looked at 27 different TSI reconstructions and have expanded that out to 40 plus since then. The IPCC has recommended just one of the 40 plus reconstructions available. The Soon, Connolly et al. Natural forcings do deviate some in the last few years, but those step increases can be tied to the strong 2015 El Nino Southern Oscillation pulse and another enhanced pulse in 2023/2024, not CO2. Ignoring solar activity is dangerous and will not produce reliable forecasts for future climate. Remember, they are self-acknowledged to run too hot and cannot explain the significant temperature fluctuations over the pre-MTR Holocene, while CO2 remain virtually flat. Now, so solar activities are not settled science either. An assortment of the TSI reconstructions are included above. Reconstructions like Lane 2000 and Ergurova et al. 2018 can be used as a direct solar forcing. As mentioned earlier, the IPCC's recommendation is the Mattis et al. 2017, which is much like the NRL, Naval Research Laboratories, TSI2 reconstruction, which I have traditionally used. Both Mattis and NRL TSI2 can still be used as proxies to model the modern temperature record. The model projections do not include the many other important solar forcings that act on our planet. Cosmic ray flux and its effect on cloud albedo and sunshine hours and high energy particles are programmed into the models but effectively turned off. Other parameters like the electromagnetic field and solar wind strength, UV frequencies, deep ocean volcanic and seismic activity, etc., are just knowingly ignored or omitted by the IPCC. That's CO2's 11th Moneyball moment. Solar activity can explain global temperature changes far better than CO2 on its own, as shown by Soon et al. And Scafida. And as discussed earlier, the reality is still very much likely a combination focusing on solar and ocean forcings with contributions from aerosols and CO2. CO2 climate sensitivity, as mentioned earlier, it's not settled science, rounds out the Moneyball moments at number 12. The IPCC uses a range of 1.8 to 5.7 degrees centigrade for CO2's equilibrium climate sensitivity in their models, which run too hot and use implausibly high emission scenarios. Suggesting the ECS value is less than 1.8 degrees centigrade. ECS is the amount of warming expected from a doubling of CO2 in the atmosphere. There are other versions of this chart out there. I produced this version using the University of Chicago's Modtron model for estimating the energy radiating out to space. Modtron models ECS is intrinsically roughly 0.8 degrees centigrade. Now, if the IPCC models were to factor in more regional solar forcings and urban heat island effects, their ECS would also fall into that 0.8 degrees centigrade range, fixing their running too hot problem. CO2's capacity to warm the planet decreases as the CO2 concentrations rise. These plots represent CO2's infrared radiation forcing only. Water vapor feedbacks, cooling parameters, etc., are not included in these estimates. William Happer from Princeton uses a version of this chart in his presentations. The model output shown here is calibrated closely with satellite measurements of the energy radiating out to space. CO2's absorption band is getting more saturated, as shown on the previous slide. The Modtron model estimates of ECS are plus or minus 0.8 degrees centigrade. At those levels, CO2's contribution to the modern temperature record warming is just 0.949 degrees centigrade, 45% of the IPCC's 2021 AR6 1.07 degrees centigrade estimate. CO2's rise to plus or minus 600 parts per million at the end of the century will add another 0.41 degrees centigrade. Those temperatures and that warming are beneficial. They're not dangerous. These charts just show some of the trends within ECS and TCR, which is transient climate estimates. Okay, as more information becomes available and are properly recognized, both the ECS and TCR estimates have been declining. That's the chart on the left from a SCAFTA paper from 2017. There have been more studies since then, and that has showed some further reductions. The chart to the right shows the full IPCC, ECS, CMIP6 range and the resulting expected warming trends. At a 1.7 degrees centigrade ECS, the warming rate in the lower troposphere is consistent with the temperature trends measured by satellite and radio sondes. That's weather balloons. That 1.7 degrees centigrade ECS is not inconsistent with the 0.8 degrees centigrade discussed earlier. The 0.8 degrees centigrade is just the radiative forcing alone. The 1.7 degrees centigrade ECS recognizes a realistic portion of the IPCC's unsubstantiated positive water vapor feedbacks. And just to muddy the waters a bit more, we need to recognize that CO2 has two cooling parameters along with its one warming parameter, infrared radiation. Those cooling parameters are not included in the IPCC models. This chart lays out schematically how these two parameters could be affecting CO2's capacity to warm the atmosphere, historically and in the future. The green curve is the ModTrend model's IR forcing, i.e. that's an ECS of 0.8 degrees centigrade, plus or minus. As NASA and others have shown, CO2 concentration increases have led to significantly more leaf cover. NASA has also shown that global greening since the early 1980s may have reduced global warming by as much as 0.2 to 0.25 degrees centigrade Celsius. Now, the blue curve on the bottom honors that NASA estimate. The gold curve just above represents the cooling that is associated with combustion-generated aerosols. Now, I included a very conservative estimate here since aerosols are already included in the IPCC model best estimates, but with very significant error ranges. And I also feel that humanity should be limiting the aerosol production to safe levels. So what happens when you add leaf cover and CO2 co-aerosols to the radiative forcing? That produces the red curve, effectively minimizing CO2's overall warming ability and potentially even reversing CO2's warming. It's flattened out towards the 800 parts per million range and would continue down a little bit after that. So to summarize things, CO2 has little to no effect on Greenland and Antarctic temperatures, which covers most of the world's land ice. CO2 has no observable effect on pre-MTR Holocene temperatures, significant climate change with virtually no CO2 change. CO2 does not correlate with sea level changes. Whatever minor effect the CO2 may cause is indistinguishable from natural variation, i.e. the warming and cooling of the oceans. Climate change, primarily CO2, has relatively small impacts on Canada's GDP growth and the world's. Climate policy will have a huge detrimental effect on our economies, our freedoms, and pile more debt on our already overburdened children's future. CO2 emissions reductions will have an unmeasurably small impact on temperature reductions, despite the trillions spent on those reductions. Roughly $10 trillion for every 1/100th of a degree Celsius of temperature rise averted. Extreme weather events are declining as CO2 levels are rising. The CO2's influence is grossly overstated. Computer models use a CO2 ECS range of 1.8 to 5.7 degrees centigrade, all too high and definitely not settled science.
Obvious natural forcings, solar and solar related, directly and indirectly, are being knowingly ignored. CO2 is a parameter that will affect temperatures, but that effect is small compared to the other forcings that act on our planet and is lost in historical data. So why are we sacrificing our way of life to reduce CO2 emissions? The all CO2, all the time alarmist narrative can be distilled down to the representative image shown above. 1, greenhouse gases, primarily CO2, drive the climate. But there are no empirical CO2 temperature data sets that show CO2 driving the climate on any statistically significant historical timescale. 2, computer projections, masquerading as proof, are showing that rising CO2 concentrations are leading to catastrophically higher temperatures. But the models are self-acknowledged to run way too hot and use implausibly high emission scenarios. They don't model the historical temperature data. 3, rising CO2 concentrations are leading to more and more severe extreme weather events. But the empirical data shows otherwise. Attribution studies have been added to the alarmist arsenal recently, but they are just a corollary to the computer projection problems and disproven by the empirical extreme weather data. That brings us back to Moneyball. If CO2 is such a good climate driver, why doesn't it drive climate? So, if I could, to wrap up, I would like to make everyone aware of a book I co-authored with, among others, H. Sterling Burnett from the Heartland Institute. It's called Energy and Climate at a Glance, Canadian edition 2024. It's a short, easy-to-read resource book, and it's available from the Friends of Science Society. My personal website has been included for those that are interested and want more detailed discussion on these and other climate-related parameters. That website is climatechangeandmusic.com.
I will put a copy of your slides out on my Substack, and I'll put a link to that. In the show description. And let's see, I'll put a link to your X feed and your link tree for Friends of Science. And then you are accepting donations for Friends of Science, right?
Of course. Yep. There's you just have to go to their site, friendsofscience.org.
Okay. I'm curious. I think one of your slides said that there was some projection of $3.6 trillion of CO2-induced damage in Canada. I'm just curious as to how that is going over with the public. That do people really believe that Canada is getting too hot and they're worried about trillions of dollars of damage from CO2? It seems pretty
not if they're being true to themselves.
Yeah.
This winter this summer was particularly cold. It was a Freudian slip. I called it winter, but.
Good. I'm glad to hear that.
Yeah.
Let's see.
No, it's people are starting to figure it out, but it depends where you are in Canada too. It's a big country, and we have our various different societal types across the nation.
So Friends of Science has been fighting the scam for a long time, right? I've had Michelle Sterling on here a couple times talking about it. I think she's a great spokesman for your.
She is awesome. Yep. Very, does a very great job for us as communications manager. Absolutely. Yeah. We've been going since 2002. A group of engineers and climate scientists at the time got together and just really didn't like what was coming out of the Kyoto Accord meetings with respect to science itself. And they thought they'd be able to put some good data out there and be done. And back to their real lives in a couple of years. That didn't happen.
I'm happy to see that you're collaborating with Heartland on that Energy and Climate at a Glance. I like that booklet. Are you working with any other organizations like Clintel or any other folks across the board?
Friends of Science has done work with Clintel, and one of our directors is with CO2 Coalition, Gregor Wrightstone and the guys there. And we talk and meet with Climate Realists of BC, which is a group out in Vancouver that have their own website. And one of the authors on the book was Paul McRae, who is with that group. And the driver for this book was John Zacharias at Sensible Climate Policy, Canadians for Sensible Climate Policy. And Tom Harris was also an author here, and he's got the international, I forget the name of it, but.
Okay. Yeah, I'll have to try to invite more of these folks on the podcast. There's a lot of people doing a lot of work fighting the climate scam. So,
absolutely.
Any other points you want to make before we finish this one up?
Well, I just want to emphasize we're just spending a whole lot of money and not getting anything back for it. And every one of those dollars spent goes on to the death for my kids and my grandkids, your grandkids, and everybody's. And it's not necessary. We're not headed. There's no climate emergency. I became a signatory to Clintel's World Climate Declaration back around 800. So I've talked to a few of the people there, and it just makes no sense. It boggles my mind, really.
I will let you go, but thanks a lot for all the work that you're doing. I really enjoy your work.
Well, and vice versa. The work that you guys do with the documentaries and all these podcasts is awesome, because somebody always gets something out of it, and the more people we can get going down the right path, the better for all of us and for them as well.